Hello, and welcome to Two Dancing Clams. This is a Blender 3.4 tutorial video demonstrating an improved workflow for handling textures on procedurally generated objects. I want a way to texture a procedurally generated object so that I can get independent control over individual faces. One way to handle this is to duplicate the texture and assign a different copy to each face or group of faces. Then you can go in and individually adjust the location, rotation, and scale. After trying this for a while, I grew to hate it. Not only did this cause textures to multiply like rabbits, but tracking down which textures corresponded to which faces was tedious in the extreme. I really wanted to have the texture controls inside the geometry nodes that produce the mesh. This is that method. Best of all, you only need one copy of the texture. The project file for this is available on Gumroad. Follow the link below. In this tutorial, I'll show you how to construct 4 easy node groups to end your texturing problems forever. Well, at least make them a little bit better forever. I'm going to do something a little bit different for this video. Because these node groups are so simple and so linear, I'm just going to take you on a tour of them rather than constructing them stepwise. Again, the project file is available for free if you want it. It's also available not for free if you prefer. The basic strategy is to create 4 named attributes in the geometry nodes, one for the UV map, and 3 others to control the location, rotation, and scale in the shader mapping node. The shader node group is trivial. So this is texture we're using. I pulled down medieval blocks from Polyhaven. That link is also in the description. And this is, the bulk of this is directly what I got from Polyhaven. The difference I made was, this is our node group. And you'll see this node group we've created, this node group that I've created this time, passes information from the face corners concerning the UV unwrap map, the location, the rotation, and the scale. Let's take a quick look at this node group. And you can see it could not be simpler. So there are 4 of these attribute nodes. The first one pulls a variable called UV unwrap, and the second one pulls a variable called mat location, mat rotation, and mat scale. And these are just fed into the mapping node. That's all. The basic reason for this node group to exist at all is to prevent me or you from having to remember the names. As a matter of fact, because the names of these attributes are saved and retrieved in these node groups, you never have to remember them. Now the next most trivial node group is the unwrap. And again, this is really simple stupid. So we just take the geometry. We are going to save the UV unwrap to an attribute called UV unwrap. Again, it is a vector, and it has to be in the face corner domain. That's all this does. And this unwrap node does the stupidest version of unwrapping by default. Basically, if you don't change anything, everything will be selected and everything will be a seam. And we fill the holes. Pop back out. And you can see these controls are here. So if you just want something simple like this cube demo that I've set up here, then this is sufficient. If you want something more complicated, of course, these can be extended into node trees that create Boolean equations that actually select the seams you want or the selections you want. The first node group is a node group that sets all the variables all at the same time. So you can plug in the location, rotation, or scale, or don't plug them in and just set them in the interface. Let's take a look at this node group. You can see it's a little bit more complicated than you would have thought. But, so we take the input geometry, and we're going to do a store named attribute, again in the face corner domain, has to be in the face corner domain. And we're going to set the mat location, the mat rotation, and the mat scale individually. We don't just take the value that was passed in. What we do is we will read the old value of this attribute, feed it into a switch statement, and then also feed the new value into the switch statement. So if this has been selected by whatever criteria has been passed in, then we will take the true value and that will be stored into the mat location. If this has not been selected, then we'll retrieve the old value and put it into the location, essentially not changing the value. But if we didn't do this, then we would change the value to something. It would either be this or something else, but we would slam it. So this is a coding technique called read, modify, write. And basically, it allows us to either change or preserve the old value rather than purely setting a new value. And what this allows you to do is, instead of having a nest of switch statements that construct all possibilities all at once so that you can only set this value once, this allows you to have as many of these node groups as you want. You could have one node group controlling location, another controlling rotation, or as you decide which faces are assigned to which texture, you can set the values in them at that point and not worry about what was done before that. Similarly, you can have one of these node groups set all the default values, and then subsequent node groups farther on down the chain alter the settings for maybe just a face or two as you choose without destroying the default value. Okay, so that's what we're doing here. So basically, read in the old value, take in the new value, decide which one to use based on the selection criteria that was passed in. And again, we do that first for location. We're going to do exactly the same thing for rotation. Read in the old value, take in the new value, decide which to use. Lastly, we'll do exactly the same thing for scale. This video is not doing much to demonstrate my imagination, but sometimes rote is good. Pull in the old value, pull in the new value, decide which to use, set it in the variable. Now, there's one thing I've thrown into this node group and the other node group. Before we leave, we will read the scale, whatever it is, whatever it got set to here or whatever it was when we came into this node group. We'll measure the value against 0, or we'll measure the distance between that value and 0. If the distance is 0, then we don't let it stay that. So if scale is 0, 0, 0, we will change it to 1, 1, 1. Basically, it is easy to make the default value of everything 0, 0, 0. But if you do that with scale, you won't see your texture at all. So this is basically a way to say, if nothing else has been set, the default value of scale is 1, 1, 1. If the user ever sets the scale value, then it'll no longer be 0, 0, 0, and this code won't run and won't have any effect. Get back out. This is the first node group, and it sets everything. And this is the fourth node group, the last one I'm going to talk about. And basically, this allows you to take either the location or the rotation or the scale and control it individually. And the reason I did this is because what I find is generally is I'll have one of these that will set the defaults, and it'll set it for everything. And then usually there's just like I'll take a couple faces and change their rotation, or take a couple faces and change their scale, or maybe both. And so what this allows me to do is to decide independently what I want the defaults to be and what I want to tweak on down the road. And again, that's another very important reason why we do this read, modify, write thing. So if this sets it for all of the face corners, and this just sets it for a few of the face corners, this one won't obliterate the work we did here. Let's take a quick look at this node group. And you will see it is almost identical to the other one, except, so we're doing the same read, modify, write, except in this case, the location, rotation, and scale are Boolean. And basically, they tell us what this value is. So if the location is true and the selection is true, then this value corresponds to a new location we want to set. If either of these is false, then we will just plug in whatever the location currently was. Similarly, we'll go down, and we'll do the same thing for rotation. So if the rotation Boolean is set, and this has been selected by whatever was passed in as our selection criteria, then we will put the value into rotation. If either of these is not true, then we will just restore the old value. Same thing with scale. And again, I will make sure that the scale is never 0. 0 is a nonsensical thing for the scale to be. If it's currently 0, that means it probably hasn't been touched yet. So the first time we see that it's 0, we'll change it to 1. And again, if the user ever changes it to something that's non-0, we will leave that alone. And real quick, I'll take you on a tour of what I did here. What I did for this demo was I just took the default cube, and that's the input for this geometry. And that's what's coming into our node group. And again, I'm setting the defaults here. So all I really set in the global scale is the scale to get something that's pleasing. Now, to control which face is which, and that's one of the reasons I picked a cube, is we can just grab the normal and grab one of the values and test it against 0. So if the z value is not 0, I know that I'm on the top or the bottom face. If the y value is not 0, I know I'm along the y-axis, and if the x value is non-zero, I'm along the x-axis. This allows me to pick one of these sets of faces. In this case, what I did was I chose the faces that are on the z-axis, and I hooked up a little animation to it. So grab the frame, divide it by 20 to slow it down, pump it through a sine wave to turn the linear motion into a back and forth motion. And now if I hit the space key to start the animation, whee! But the key to this is not the stupid little animation. The key is the fact that even though everything in this is sharing the same texture, the only faces that we're modifying when we do this are the top face and the bottom face. So for example, one of the things that's very common to do is you can see the pattern in the top face and you can see the pattern in the side. That's a natural. I want to rotate the side so that it matches the top face, so they look more like blocks. Go down here, and this is where we're along the x-axis, so we want to find those places where the x value of the normal is non-zero. And I'm going to take that up here and pump it into one of these node groups that controls just one value. In this case, I'm going to control the rotation. You can see what we want is pi over 2. And that allows us to make this guy line up with that guy. And now, if I want to make this side line up with the top, we have this Boolean down here, and it's selecting out the x face. And we're running it into two different copies of this separate scale. By the way, geotext, it doesn't really mean much. It was just an easy way so that these 4 node groups could have a similar prefix, so I could find they'd all be adjacent to each other in my asset browser under groups. Feel free to change it to anything you think is more appropriate. So now we can just, voila, quick recap. Take the standard cube, run it into this, what I call geotext combo, basically to set the rotation, location, and scale for everything globally. And then from then on, we can make individual choices based on selection criteria. So in my case, face normals show up a lot for how to make these selections. That gives you individual control over not only which face corners you select, but also whether you want to set the location, rotation, or the scale. Lastly, we have this unwrap node, which is by default trivial, but can be expanded to any degree of complex unwrapping that you need. And this will save the UV map into the face corners for the shader. Lastly, in order to make this all work, you'll want to set material to the texture that you've created or downloaded. And then in the texture that you've created or downloaded, in this case Medieval Blocks 3, add this geotext shader group to take all these values that you've set up in geometry nodes and pass them directly into the mapping node inside the shader. And that is it. I hope you enjoyed this video. Thank you very much for watching.